Hi and welcome back to Gaffy's Grinds. In this video, we are going to discuss the solubility of alcohols in water. So in the previous video, we learned about alcohols, we learned about primary, secondary, and tertiary alcohols. And in this video, we are going to look at their solubility. How easily do they mix with water? Now, previously, we learned about water and we learned that it has a V-shaped molecule like this, OH2 or H2O. And we learned that the OH bonds are polar, which means that the oxygen attracts electrons towards itself and the hydrogen loses electrons because oxygen is taken away from them. Now, it doesn't lose full electrons, but it partially loses the share of its electrons. So that leaves the oxygen the hydrogens with partially positive charges. We call this delta positive, partial positives, and that leaves the oxygen with delta negative charges. Now, because of the shape of the molecule, then we have two clear opposite ends, or we say we have a dipole. And that just means that the electrons from the bonds are kind of at one end of the molecule here. So we say that this is the delta negative end of the molecule, and this is the delta positive end of the molecule. We say that the molecule is polar. It's got two oppositely charged ends. Now, if we want something to combine and dissolve and mix with water, then it should also be polar because that lets the new molecule that we're adding into the water interact through either dipole-dipole attraction or hydrogen bonding with the water. Now, we've previously seen tetrahedral molecules, for example, methane, CH4. This is a non-polar molecule. And if you don't understand why that is, then I suggest that you should go back to videos where we did polarity of molecules before you do this video. But in this video, we're not going to talk about alkanes anymore. We're talking about the alcohols. So here is an alcohol. And alcohol will typically have some kind of a carbon chain. It might be one carbon here with just a hydrogen, or it could be a carbon chain of maybe 3 or 4 hydrogens. But the thing about alcohols is on one of the carbons, they have this OH group like this, OH group. Okay, so this could be literally just one carbon here with 3 hydrogens, or it could be one carbon with, loads of carbons attached to it. And that just depends whether it's a primary, secondary, or tertiary alcohol. What's important here, though, is this section down here, the ol group. Okay, and the reason for this is, again, we've got a similar thing going on to we did over here with the water. We've got an OH bond, and the OH bond, just like it was in water, is polar. And what that means is the oxygen attracts the electrons in the bond towards itself, which means it becomes delta negative or partially negatively charged. And this leaves the hydrogen partially positively charged. So this creates a polar bond. Okay. And essentially what this does here is it creates a dipole. We've got a dipole created. And now what happens is if we introduce it into water, we mix it with the water molecules, well, as you can see, what's going to happen here is that the water molecules, the delta negative oxygen, will be able to hydrogen bond with a delta positive hydrogen. So remember what hydrogen bonding is. Hydrogen bonding, it's an intermolecular force, and that's why I'm drawing it between two molecules. It's an intermolecular force between two molecules. Okay, intermolecular force. And it's an attractive force, so it's sticking them together. Intermolecular forces, and it always occurs between a delta positive hydrogen atom of one molecule, which is here, delta positive hydrogen, with a delta negative O, N, or F of another molecule. And that's this here, delta positive O. Okay, so that means that this here is a hydrogen bond. And when hydrogen bonding can occur, you will get dissolving or miscible liquids. These two liquids can mix together. So because we've got hydrogen bonds, or because we've got a polar molecule mixing with polar water, the general rule is like dissolves like. So because they're both polar, water is generally going to dissolve alcohols. And this is true most of the time when we're talking about small alcohols. If we make the alcohol chain very, very long here, well, then we've got this small bit at the end, which is polar. And then we've got all of this alkane chain type of thing going on, which is non-polar. So if we make the alcohol very, very, very long, then this non-polar thing tends to overpower the polar part. The kind of rule here is that short alcohols can dissolve in water, but long chain alcohols become less and less soluble, and very, very long chains won't dissolve at all. Right, so just going to go over here and read a little bit about solubility, make sure I haven't missed anything. So it says, as we've learned previously, the solubility of a substance depends on the polarity. Some tetrahedral compounds are completely insoluble in water due to being non-polar. For example, the alkanes. Alkanes don't mix with water. They will, however, dissolve in non-polar solvents like cyclohexane. So non-polar, non-polar. In this case, water is polar, so are alcohols polar is the question. Well, the OH bond in alcohols, as you can see, creates a dipole, and this gives us separate parts of the molecule. We've got a delta negative part and a delta positive part of the molecule. This means alcohols can dissolve in polar solvents like water, but not very well in non-polar solvents like cyclohexane. The hydrogen bond in between the alcohol molecules means that their boiling points are reasonably high for the molecular weight. So that's, we've done boiling points already in a previous video, so I'm not going to do that in detail here. This was about solubility. Solubility, small alcohols can dissolve in water, but longer alcohols cannot dissolve in water. All right, so what we're going to do now is we're going to get you guys to pause the video and we're going to work our way, first of all, through question 24 down to 30. All right, pause the video and do that now. Okay, and then a continuation of that is we're doing 31 and we're doing 32. Pause the video, do those now. Okay, so very quickly, do you know what? We're going to go through these in class the next day, guys. So if you guys found this useful, please leave a comment down below. It helps other leaving cert students to find these videos in other schools, and it may help them as well. Okay, so thanks, guys, and I'll see you in the next video.